There is something that has been bothering me since we started deploying the model that we created. And I mentioned this before. Our model is not capable of handling raw data. Our model requires us to pre-process the data before we actually run that data through the model to get a prediction. And that sucks because when we deploy that model, that creates an endpoint, or we create an endpoint that requires somebody else to pre-process that data. So instead of having an endpoint that's responsible for just taking a request and producing the proper output, we have something that requires another third party, another service to work in order just to create that or pre-process that data, transform that data in a specific way. And that makes for a brittle endpoint. If we deploy an endpoint and we're gonna need like a Lambda function in front of that endpoint to just pre-process that data. If we change the rules of how that data needs to be pre-processed, then the Lambda function or anyone using that endpoint will also need to change those rules. So we don't want that. Look at this diagram. This shows you what our endpoint, our prediction service requires right now. You can see that that prediction service requires a Coleman length, but not in millimeters though. Requires a Coleman length that has been standardized. That's what our transformation process does. It expects a Coleman depth, the flipper length, the body mass, and then it expects like a one hot encoded vector for the island. So we need to pass 1 or 0 for island Bisco, 1 or 0 for island Dream, and 1 or 0 for island Torgerson. The inputs are all messed up, but the outputs, well, the endpoint, the prediction service, returns a softmax vector. So it doesn't tell us what the penguin species is. That's something that we will need to determine by just looking at that softmax. That is not what we want. Instead, it would be ideal if we could create something that expects, if I scroll down, it would be ideal if we can create an endpoint that expects a JSON input just like the one that we have here. Raw data. The island Bisco, the Coleman length in millimeters, the depth in millimeters, the flipper in millimeters, and the body mass in grams, right? Just the raw data. And it would be ideal if that endpoint answers with something that's human readable, right? Like prediction is Adelie. Not 0 or 1 or 2, but Adelie. This is the name of the species, right? And a confidence value. So how do we accomplish that? Well, there are multiple ways to get there. And I'm going to see right now the method that it's probably the most exciting one to get to this point. I don't know how to define it, but it's just creating an inference pipeline. That is what we are going to do. So let me show you this diagram here. I'm gonna go to session 1. Remember that the last time we took a look at this diagram, I asked you to just forget for a second that inference pipeline. This is what we're going to be building today. Instead of deploying the model that we're training directly to an endpoint, I'm going to create and deploy an inference pipeline. And that inference pipeline is going to take care internally of pre-processing and post-processing the output of the model. So pre-processing the data that comes in and post-processing the data that goes out of the model. Here, you can see there are going to be 3 components within that inference pipeline. A pre-processing component, the model that we built, and a post-processing component. That is what we are going to build. So here in this other diagram, I'm trying to give you an idea of how this is going to work. We're going to build this inference pipeline, and these are the 3 components that are going to be living within that inference pipeline. We're going to expect raw data. We're going to have the transform component or pre-process component that is going to get the raw data and transform it into the data that the model expects. Then we're going to call the model, and then that model, the output of that model is going to go to the transformation step that is going to turn the softmax predictions into the name of the species and a confidence value. And those are going to be the outputs. Given the inputs, those are going to be the outputs that we are going to get. That is what we want to build in this session here. Now, how do we do that? We're going to use something that's called a pipeline model. It's an inference pipeline. A pipeline model in SageMaker will allow us to have one single endpoint running multiple containers inside, where each container will communicate with the next one within that pipeline. So basically what we can do is have one container, one model, quote unquote, that takes care of pre-processing the data. The second model is the model that we already trained. And the third model is going to post-process the data. How do we do this? Well, we just need to create the three models. We're going to create those three models and we're going to deploy them together as a pipeline model. We're going to just put them together in an array. We're going to say this is a pipeline model, and SageMaker will take care of communicating the output of the first model as the input of the second model and the output of the second model as the input of the third model. Let's start by focusing on the first model, or the first component, which is the pre-processing component. How am I going to build this? Well, I'm going to be dealing with raw data and I need to transform that raw data. How do I do the transformation? Well, remember that as part of the pre-processing step, session 3, I think, we created a scikit-learn pipeline and we fit that scikit-learn pipeline to our trained data. And that scikit-learn pipeline is capable of transforming the data. What we need to use as part of this pre-processing component is reuse the transformation scikit-learn pipeline that we generated in session 3. That is one of the outputs of that pre-processing step that we already have. So we need to reuse that. So this component requires scikit-learn, needs to load that pre-processing pipeline in memory, needs to process the data that comes in, and that's it. That's what we need to build. So these components, or the components of the pipeline model, are all of them are models. So we are going just to create a model. In order to create a model, we're going to create a script. That's what the inference script that the model is going to run. When you create a model, SageMaker gives us sort of like an interface that if we follow that interface, SageMaker will know exactly how to run that model. That is what we want to do right now. As a reminder, we created already a model. We did not need to specify an inference script because we didn't need to just have sort of like a custom inference process. In this component that we're building here, we're going to be creating that custom process. So let's see what that looks like. First of all, I'm going to start by creating a folder. I'm going to call that folder pipeline. I'm going to add it to the system path so we can test whatever we put inside that folder. This is the pre-processing component. Remember, this is the script that is going to be the code that SageMaker will use to run inference on this component, on this model. So the interface that we're going to follow is very simple. There is a model function that we need to create, an input function, a predict function, and an output function. Those are the 4 functions that we need to define. We define those 4 functions, and SageMaker will take care of calling those functions at the appropriate time. So what are those functions for? Well, the model function needs to load the model in memory. It has to return the model that later on will get passed to the predict function. So how do we do this? Well, we are going to load the scikit-learn features pipeline in this function. When we deploy this model, we need to expect that that features pipeline is going to be available to this model. So within this model function, we're going to load that in memory. This is what I'm doing here. If you remember, we stored the features pipeline, the scikit-learn pipeline, using joblib. So I'm going to use joblib to load it back in memory. So that is exactly what I'm doing. I'm saying joblib.load, load the features.joblib, which is the scikit-learn pipeline that is already fitted to the training set. We already did that in the first step, or in the third session, the first step of the pipeline, load it in memory and return it. That is the model that this component is going to use. And later on, I'm going to show you how you make that features.joblib available to this function here. But for now, that is what's happening. I'm loading it from the model directory. The input function receives the input data, and it receives the content type of that data, so the format in which that data comes. This input function needs to handle what it's going to happen with this input data, and it needs to return the data as a data frame. So whatever we pass in here, JSON, CSV, doesn't matter. I need to return a data frame. So let's see what I do. I'm saying, if the content type is text CSV, if the data that the endpoint receives comes as a CSV file, I'm going to turn that into a pandas data frame. So basically read that CSV from this input data. There's not going to be any header, so don't try to get one line as the header because there's not going to be any header, and skip any initial spaces. So I have a data frame. I now need to make sure that this data frame does not include the target column. I'm making an inference prediction here. So I'm just going to get rid of any potential target columns. I'm going to say if the number of columns is one more than the number of features that I'm expecting, and I have a constant here, right here, with the features and the order that this endpoint is expecting those features. So if there is one more than the one that I'm expecting, drop the first column. So I'm assuming that if there is one more, it's because the species comes in the first column. That is what the original data it looks like. Just drop it, so we don't deal with that. Set the columns, the name of the columns of that data frame, and return that data frame. This is what the input function does if we receive text CSV. What happens if we receive JSON? Well, if we receive JSON, I'm going to load the JSON data as a JSON object, and I'm going to just create a data frame using that JSON data. You can create a data frame off of a JSON object. It's very simple. So this is how you do it. And if the target column exists in the columns that were passed to me, just drop the target column. Pretty much this condition and this condition will have the same effect. They're just dealing with data in different formats. And then obviously, if the content type is neither text CSV or application JSON, I'm just going to raise an exception. So this is my input function here. What is the predict function? Well, now the predict function receives the input data that comes out of this input function and the model that comes out of the model function. And remember, SageMaker is the one calling those functions for us. SageMaker will use the script and will make calls to the functions as it sees fit. Okay, so cool, awesome. So the predict function is going to call model.transform. Remember, our scikit-learn pipeline has a transform function. We used that function as part of the split and transform processing step. We're going to call transform to turn the raw data into the data that our model expects, our TensorFlow model expects. So I'm just going to call model.transform, and that is going to be the response of this predict function here, which, by the way, it's gonna look better if I do this. So just return the result of this model.transform. And if there is an exception, I'm just gonna return none. And then the final function. The final function within this component is going to take the prediction, which is the result of this predict function, and is going to determine based on the accept criteria or the accept content type sent by the client, will return the output. We need to remember that in our inference pipeline, this component will sit in front of the TensorFlow model. So we need this component to return the data in a format that the TensorFlow model expects. That is what this function is going to do. So this function is going to ignore this accept, doesn't care about that. What it needs to do is return the data in the format my TensorFlow model is expecting. So I'm going to go here and I'm going to turn every line into an array. So I'm going to get an array of instances. This is what that will look like, instances, and then that array. And I'm going to pass this. I'm going to send that as a response. Notice that I'm using here, this class is called worker.response. This worker I'm loading only if this import is available. What happens is that when SageMaker runs this in a SageMaker environment, we're going to have access to that SageMaker containers.beta.framework, and we're going to have access to the class worker. The file worker, not a class. Worker is like a module. So that module worker contains a response class, which is a Flask response. So I'm trying to import it here if it's available. And if it's not available, I'm going to set it to none. And the reason I do that is because if I want to test this file locally, that is not going to be available here, so I cannot test it. So I do that try except, and then here at the time of making a response, I can just create a response directly like this, just send the response with the accept back, or use the response class that's part of that module if it exists, where I'm going to dump that response as a JSON and I'm going to return it like this. So again, that is just a fork here in the code where it's going to run differently if it's running in SageMaker versus running here in my computer. That is the script that I need to be that first component of my pipeline. The next cell here tests that script. And I think it's like 8 different test cases that are just going to make sure that it works for CSV, it works for JSON, and it always returns the input in the appropriate format for my TensorFlow model. We already have the TensorFlow model, obviously. We need to worry now about the last component. We already have the first component. We have the TensorFlow model. We need to worry about the last component. And the last component, the goal is to take the output from the TensorFlow model, that's going to be the input to that last component, and create the proper prediction, Adelie or Gen2 or Chainstrap. Those are the 3 species, and a confidence. That's what we need to do. Now, where do we get the name of the species? Well, if we go back to, let me go to session 3, which is where we created that split, that processing step, or that split and transform step. If we go to the script, I want to remind you of this. We had a target transformer and we had a features transformer. And then we have a function that saved that as a model. So this save model here, I saved target.jotlib and I saved features.jotlib. The first component of our pipeline inference used the features.jotlib. That is how we transform the data. But I also have a target.jotlib that I used that target.jotlib to, I think it was an ordinal encoder. Let's just make sure that's the case. Exactly. So see this target transformer, which is the target.jotlib, is the transformer, the scikit-learn transformation pipeline that I'm saving. It was a transformer to transform the species column using an ordinal encoder. Well, what's good about that is that this transformer, after I fed it, this transformer now contains a mapping between Adelie and 0. So class 0, there is a mapping internally within this variable that indicates what class 0 means, what class 1 means, and what class 2 means. So we're going to have something like 0 is Adelie, 1 is Gen2, and 3 is Chainstrap. So what we need in the third component of our pipeline inference is access to this target. If we have access to it, we can get the name of the classes and we can do the back conversion. So we can turn the proper prediction into a name, into the species name. That is exactly what I'm doing here. So let's go here to step number 2, which creates the post-processing script, the third component of my pipeline inference. And this is going to follow exactly the same format with the 4 functions: input function, model function, predict function, and output function. Let's see the actual code. The model function, look at this, I'm loading the target.jotlib, but then my model is just an array. My model is an array with the name of the classes. So out of this model, I'm getting named transformer species because in my transformer, I named it species, and I'm getting the list of categories. This is going to return something like this. That's what I'm returning. I'm calling this for the purpose of this component. My model is just going to be an array with the map, right? Position 0 Adelie, position 1 Gen2, position 2 Chainstrap. So I'm returning that here. The input function expects the data coming from the previous component, which is the TensorFlow model. So what comes here is the result of the TensorFlow model. the prediction. So I'm loading that. We know that the TensorFlow model always returns a JSON object back, and that JSON object has a predictions inside, and predictions is just a softmax array with 3 positions. So what I'm doing here is I'm turning the input data into a JSON. I'm loading it as a JSON, grabbing the predictions key inside that JSON. We know that's the format, and that is the list of predictions that I'm going to return. And I'm going to do the same thing that I did here. We don't need it like a different variable for that. I'm just going to do it like this. Cool. That's the input. What is the predict function then? Well, the predict function receives the input data, which is, now we know it's just a softmax array, and receives the model that we know is just the mapping, Adelie, Gen2, Chinstrap. So I'm going to grab the argmax to know what index is the highest one. That is the appropriate class that I'm gonna put in predictions. So I'm gonna get an array with the index of every class. I'm gonna get the confidence, which is the max value. The highest the number, that is the confidence. The highest number is the confidence. And then I'm gonna return the following. Look what I'm doing. I'm returning a tuple where the first position is the name of the prediction and the second position is the confidence. And it's just an array because there might be multiple requests. Like I might have gotten a batch of penguin data. So I need to return predictions for each one of those samples. So I'm just doing this for getting the confidence and the prediction in confidence and predictions zipped. So I'm zipping that so I get tuples that I can read, and I'm returning them like this. I'm going to show you in the tests what they look like. Final function is the output function, and this output function here, getting a prediction, and the accept, this accept is coming from the client. Here, if the client wants to receive CSV, I'm going to return the data in CSV format. If the client wants to receive application JSON, I'm going to return the data in that format. So if the client wants CSV, I'm going to return just a tuple with the prediction and the accept criteria. It's that simple. And again, as a reminder, this worker here just creates a class for Flask to return that. It's a little bit fancier, but that will only work when this model is running in SageMaker. If the client wants JSON, then I'm going to create a JSON object that contains the prediction and contains the confidence value. And obviously, if there is only one prediction, I'm not going to return an array. I'm just going to return like a top level value, prediction and confidence, not an array, just to make it simpler to read later. That is it. This is the second component. Now let's test this second component. As you can see, let's look at some of the unit tests that I have here. Okay, so look at this test. Predict returns prediction as first column. If this is the input data that I pass to the predict function, I'm just testing the predict function, and this is the input data, which are example softmax values. I pass that input data and the potential model, which are these categories. I want the response to be an array with Adelie first and then the confidence, then Gen2, then the confidence. So this is what the response will look like of that function. This is just me testing that specific predict function. Output does not return array if single prediction. This is the last thing that I said, that if I pass a single prediction in, I want the response to be plain, not an array. It's easier to read like that, to use the endpoint like that. Anyway, there are 3 functions here. There are 3 tests that I'm testing. Let's create my inference pipeline. To create the inference pipeline, first I'm going to create this variable here, which points to the model returned by the pre-processing step. This is the output of the pre-processing step, and the output is the model output, which again, I remind you, contains a model.tar.gc file. Inside that model.tar.gc file, there is a target.jotlib and there is a features.jotlib, the 2 scikit-learn transformation pipelines. This model.tar.gc is what I'm going to pass as input to the first component and to the last component of the pipeline. And SageMaker, because those are models, SageMaker will automatically take this model.targc file and extract, uncompress that for those 2 models to run. That will give me access immediately to the content of those. So that's great. So I'm creating this variable here using the join function. You already know how to use that function. Basically taking this URI and putting it together, concatenating that URI with the name of the file using a slash in the middle. And now I define the 2 components. Both components are models. And because what I need for these models is scikit-learn, I'm going to use an sklearn model class. If I needed TensorFlow, I could have used a TensorFlow model class. If I needed something specific, I could have used just a base model class and specify the containers. But because SageMaker offers an sklearn model class out of the box, that will have inside internally, that will point to a SageMaker container that we can use to deploy this model and run this model. Look at this sklearn model class. The model data, what is the model data? What is the model.tar.gc file that SageMaker needs to uncompress for this model to work? Is this variable that I just created here. So I'm giving this model access to the scikit-learn pipeline. The entry point is the script that I created, the pre-processing script. The source directory is the folder where that script lives. Framework version is 1.2-1. That's the latest scikit-learn container that SageMaker supports. Then I specify the SageMaker session and I specify the role. And this same thing I need to do for the post-processing component, which is this one here. My post-processing model is the same values except the script, which is going to be the post-processing script. Now I have those two models plus the TensorFlow model that I created in a previous session. So this is how I put together this pipeline. I have a pipeline model. I'm going to call it Inference model. The list of models I define like this, and here the order matters. First, I want my pre-processing model, then I want my TensorFlow model, and finally I want my post-processing model. So what you're seeing there is this: the pre-processing first, the TensorFlow model second, and the post-processing last. That is what you see here. So going back to that line, I specify a session and whatnot. So now, instead of registering the model, the TensorFlow model directly, we can register as part of the pipeline this pipeline model, right? And this pipeline model contains another 3 models that are gonna work together. That is exactly what I'm going to do. I'm gonna create a new group to register this type of model in a separate group. I'm calling them pipeline penguins. It's a separate group. I'm gonna go and change my register step. And in this register step, I'm going to pass the new group. I'm going to change the content type and the response type because we implemented this pipeline model to support both text CSV and application JSON. Before, the basic Penguin model only supported text CSV. Now we support both, which is great. It's a better model. So I'm going to specify those two here and the same model metrics that we created before. I'm going to modify the deployment step. So I'm going back to a pipeline that automatically deploys my model. So I'm going to create deployment step with the new register model step. I'm going to modify the condition step. So I add the register and the deploy step back to the condition step, and I'm going to create my pipeline 14, which is the same thing that you saw before. It's just pointing to the new steps. If we run this, this is what you should get. If we go to Studio here, I ran this before off camera. So let's go there, session 14. Here is what I ran. So this pipeline will look exactly the same as the ones that we saw before. There's nothing different except the model is going to get registered under a different model registry group. So if we go to the model registry, we're going to find the pipeline penguins, and right there I have version 10. Let me show you something within version 10. If we come here, we get the model metrics. That's awesome. Under Inference, they have a section here, containers. And if we go there, look at this. Within this model, we have 3 different containers. We have the first container is a scikit-learn container for our pre-processing script, then the TensorFlow container, and finally another scikit-learn container. So what's happening is that our data is coming in and there are 3 containers handling every request: pre-processing component, inference, post-processing component. Awesome. So this pipeline also deployed the model. So here is the new model. It's deployed. Let's test it. Let's go down here. Step number 9 is going to test this endpoint. And I want you to pay attention to this because now it's a little bit different to what we did before. This endpoint now expects raw data, not pre-processed data. We can send data as we capture it on the field. So I'm creating a predictor, and notice that I'm specifying I want this predictor to be able to serialize data in CSV format. I'm going to grab the original Penguins file just so I can send a few samples. I'm going to read it, and then I'm going to drop the species column, and then I'm going to grab 3 items from that. So I'm going to grab 3 samples. I'm going to turn them into CSV, and I'm going to print them out here. And you can see what that is, what the data is. This is the payload that now we can send to this endpoint, which is awesome. We can actually send raw data. We don't need to transform that data anymore. See, this is the island. We have the Coleman. We have the flipper, we have the body mass, we have the sex that we know that the transformation is going to drop the sex, but either way it's right there. And then we wait for the endpoint in case we run this while the endpoint is just being created. And then we can call predict. And here I'm saying, please, the content type that I'm sending here is just text CSV. Okay, awesome. We get the response back and we print what the result is, and you can see now what that result is going to be. Beautiful. So we get the prediction is idly. We don't get any more the softmax. We don't get a number, and later we have to figure that out. We get what we want out of our endpoint. But there is another test, and this test right here now sends a JSON file, not a CSV, but a JSON file. So here is a sample data with my JSON file. Okay, with all of the data here, and I create a predictor, but now I'm using a JSON serializer. And by using this JSON serializer, now I'm telling the, hey, I'm gonna be passing JSON here. So I'm gonna just call predict with this sample, and I'm gonna be getting back another JSON object with the proper format here. And one thing that you can do as a reminder, you can get like a sample like this. Let me just copy it here. You can go to the endpoint, click on the endpoint. You can go to test inference, and you can pass what the content type is going to be text CSV. I'm going to paste that CSV. You can send a request, and here you can see how you're getting a response back, right? It's a shame that you cannot specify what type of output you want. You should be able to, but here you cannot specify that, unfortunately. But anyway, we will see in a future session how you can change the output type, how you can tell the endpoint, please send me back CSV. Instead of sending me JSON, just send me back CSV, and the endpoint will work because we programmed it to work with supporting both content types. In the next session, we're going to talk about a different way of implementing this inference pipeline, a way that's a little bit simpler than this. So I'll see you then.